Hello and welcome to DVCon 2021. My name is Chuck McClish from Microchip. I'm going to be going over the first half of this paper that I co-authored with Dillan Mills called How to Overcome Editor Envy. Why can't my editor do that? In terms of the motivation for this paper, the end goal is to have an editor that fully comprehends SystemVerilog and delivers all the features expected of a 21st century editor. Um, a lot of other languages have really cool features for their editors, and it feels like SystemVerilog is getting left behind. We did some analysis on this, and it kind of comes down to a couple major reasons. One is that SystemVerilog is extremely complex, and you'll see these little bar graph to the right where we looked at number of observed keywords and number of lines in the BNF and how long the standard is compared to Python. And you can just see SystemVerilog is just huge. There is a lot of stuff going on here. And the second major reason is hardware engineers are typically not software people. Software people can write their own tools because they have all the skills and all the time in the world to go and do that. Whereas hardware engineers, we have really tight schedules. We work with a language that doesn't lend itself to building tools off of. So how do we get to this point where we're on par with all the other software languages out there? So the typical approach to this problem is called the M by N problem. So when you have an editor, it needs to support all the languages individually. So for SystemVerilog, Python, and C, like I have here, if you want to get that into Emacs, the best editor, you will have to go and implement each one of those independently. And then you'll have to do that again for Vim, and you have to do that again for Eclipse, and you have to do that again for all these other editors out there. So what happened a few years ago is there was a concept of a language server protocol that was put forth by Microsoft and the people that do the Eclipse editor. And the language server protocol basically sets up a common framework so the editors can understand languages without having to do all this over and over again. So the concept is you have a server which takes your entire code base, tokenizes it into a list of tokens and symbols that it can understand, and then your editor can go and query this server and ask it information such as where is this class defined and where is this class referenced, or I want to go and refactor my design, where do all these symbols exist, and so the server does all the heavy lifting. And then the client side, on the editor side, that's your user interface. So, for example, if you're banging away in Emacs, you can, do your magic key chord and go and query the LSP for take me to the place where this class definition is, and it will take you there. So the language server protocol has quite a few languages already supported, but SystemVerilog is not one of them. So the whole pitch for this paper is how can we get SystemVerilog support in the language server protocol? And then we'll go over some examples of some cool features that this thing can do, to kind of get people excited about this idea. So without further ado, and I know this picture is kind of fuzzy here, it's zoomed in. Symbol lookup is probably the most basic and useful features. It allows you to hover over a symbol with a mouse or do a key argument or key chord to go and spit out information. Such as arguments or display documentation. You can look up the definition or declaration. You can search for references. When you're looking at a class-based design, such as you're looking at UVM, for example, you really want to know where all this stuff is without having to go and manually look things up in some language reference manual. Next is intelligent code completion. So this one is also extremely useful in class-heavy test benches. So after each character is typed, the editor will go query the language server for any relevant symbols that match this relative to the context, and that's very important. There are some editors that do this type of stuff now, like Sublime is one, but it just has a dumb regex type of check. It will just look at the whole design and it will just regex and go and search for anything that matches it at all, whether or not it's relative to the context or not. So the context is very important. If it can't find it, then the tool is telling you it's not here. So that can help you find issues before you even knew you had a problem. So next is macro expansion and peaking. So there's a lot of macros floating around out there. I don't have a picture for this one. But macros are very useful for abstraction and configurability, but they can lead to very dense and hard to read code if you don't know what's going on underneath those macros. So macro expansion can show you the true definition, or you can replace a macro with its true text and edit it from there. So some of the waveform viewers or the graphical debug tools from the simulator companies, you can click on the macro and it'll expand it and you can kind of see what's going on in there. What we're asking for here is, can we get this inside of the editor? And with the language server protocol, you can. Another one is standardized indentation. I'm a space guy because I'm getting old. I know a lot of these newer guys love their tabs. And then you get that guy every once in a while who's like, oh, I use both, which is just wrong. Just wrong. Pick one. So SystemVerilog has a lot of syntax. There's a lot of different indent styles. And different editors use different rules, and people have configured their editors to do different things. So if you are in a workspace where everybody has their own editor and everyone has their own editor flavor configuration that does their own things for their day job, you're going to run into a lot of this weird stuff. And then you import external IP, and then they have their own stuff. Yeah, it gets very interesting. But because the language server understands all the symbols and understands how everything's built, it's possible to adjust all the indentation to match a common framework. So as long as all of the editors can read in those rules file, then everyone, when they type, automatically just formats the stuff so that everyone's happy. The next one is signal tracing. So SystemVerilog is a lot different than quote normal software languages in that it represents physical hard wires and logic. There's always this concept of drivers and receivers. So GUI debug tools do this already, and they're able to trace connectivity. So if you're looking at, say, this flop here in level B, and you want to know where the data pin is being driven from, it'll go traverse the hierarchy and go walk back and go find where it is. If you're doing this with just an editor and you have to go walk through and figure out where it is, it can be very painful, especially if it gets renamed to every level of hierarchy. And I tell people, don't do that. Sometimes you can't avoid it. Sometimes you get external IP. What can you do? But with the LSP, you can enable custom language features like this signal tracing feature that we have. And then the client sides just have to have commands that go and query that information. Another interesting feature that I'd like to bring up is we live in a world that's not just SystemVerilog. There are all sorts of other languages and standards. I put a few of them on here that we deal with in our day jobs. We've got UPF. We've got Tickle for all of a lot of the tools that we use, particularly the implementation tools. You've got System C floating around in some test benches. You've got VHDL, either design code or test bench code. And then when you get to gate level simulations, you've got the standard delay format. So this idea is, after you have SystemVerilog, the language server built, why not build it for these other languages, particularly IEEE standards like UPF. But even the Tickle language, if you bought an implementation tool from a vendor and they have all of their Tickle commands, wouldn't it be nice to be able to pull up their Tickle language server and trace through your implementation code? that would be really, really cool. And then being able to link all of these things together. So say you have your UPF language server and it connects to your SystemVerilog language server, and you can trace through what's being driven in your UPF file, for example. All these things could be very, very handy. And a lot of the GUI debug tools have this stuff, but you have to go and compile the design and get all this information in there. Whereas on the language server, it's right there at your fingertips with your editor. You can debug this stuff on the fly and go and add and change things. So at this point, I'm going to hand it over to Dylan, who's going to go through the rest of the paper. Thank you very much.
Hello, everybody. As my colleague Chuck stated, I am Dylan Mills, and I will be going through the rest of the slides today. So another feature that we are hoping to see in a language server protocol implementation for SystemVerilog is supercharging our log files. There's a few features that would be really cool to see. First one would be for all of the various messages within a log file that point to a particular line number. It would allow you to quickly jump to that code from the log file or from the command prompt if you're using a compliant editor and it's built-in command prompt, you'd be able to do the same. This would make it very easy to return to the code in question when there's a statement in the log file that you want to examine further. With the macro support we talked about earlier, this would allow you to jump to the true line of origin instead of the pre-macro expanded line, which can cause frustrations when looking through log files currently without knowing which line the code is supposed to be pointing at. A slightly more advanced feature that would be very awesome to see as well is advanced parsing, such as cataloging UVM messages by type and allowing you to quickly jump through a list of errors or filter the log file based on message type. The next feature we are talking about is on-the-fly linting. Now, when most people think of an advanced editor, this is usually the feature that comes to mind. What this does is as you're writing your code, if you type something wrong or if your code is basically not going to compile or it's going to have a warning when you compile, the editor will immediately give you that feedback as you're typing in line. This effectively will remove the churn of writing code, then compile, then fix your errors, then go back and write your code again, and then compile, and then fix the errors, repeat. And if your design is extensive or your test bench is kind of large, sometimes that compile step can take some time. And this makes it so much quicker to get through that process to the point where you're actually simulating. Many of the editors will include a tracker that lets you quickly jump to all your issues and just go through the list of issue 1, issue 2, issue 3, get them all resolved, and then compile once without any errors. It is a very nice ability. The next feature is called hierarchy references. What this allows you to do is peek at or jump to a source class from an object or to a parent class from a child class. In the image example on the right, you can see where we have the MyClass class, and its definition is opened inline for you to quickly view what its definition is. And you can also, from there, jump to the definition itself in code and view it further. Within SystemVerilog, of course, we have a lot more than just classes and objects. We also have modules, interfaces, and other constructs unique to the language. And I would expect these would all be supported as well in the hierarchy reference feature. Refactoring is another feature that especially those who have used IDEs in the past might be familiar with. Refactoring allows you to easily reformat your code. It lets you rename variables and work with other named components and across your test bench. It's a bit more advanced than a simple find and replace, which is what we're used to most of the time. Because it is contextually aware of your signal names. So if you have a signal name like you see in the image where I have a signal named class var, I'm able to enter a new name for it, new class var, and it will rename every reference to that class var intelligently. So at the bottom in my class 2, I have a class var, and it's left alone in my refactoring. This lets you, and this will work across files, across your entire test bench, and it will intelligently track your class signals and other names and allow you to refactor your code with ease. It will work with, as I said, it'll work with any named component, your variables, functions, classes, signals, modules, ports, anything with a name, and will allow you to change it across all your code with ease. So that covers all of the standard features you'd expect within a SystemVerilog language server protocol. But within our lovely industry, there's no need to stop there. We have many possible extensions you could add, and these are great candidates if a vendor wanted to upsell and add additional features that might not be available by standard. We have a few that we wanted to go through pretty quickly. We're not going to spend a lot of time covering them, but they are ideas you can get out there and start thinking about how we can make a language server protocol even better and more useful to us as engineers. So the first of those ideas is, a test bench builder. Many vendors already offer one. If we integrate it into the language server protocol code, it'll streamline our test bench creation where we can set it up all right in our standard editor. Another idea is an assertion writer. There are many possibilities with an SVA-aware language server protocol. You could have context-aware code completion. You could have warnings for common SVA mistakes and issues. You could have warnings for assertions that could spawn a huge amount of threads, possibly in case you're not aware to do that. You can kind of have your editor warn you about possible issues you might see with your assertions. The next possible vendor extension is a cover point expander. There's a few things you could do here. You could have, kind of a quick macro type of cover bin group expander where you could give it a signal to expand, and it could give you common cover bins for the particular signal size. I'm sure there's many things we could think of beyond that. That was just a quick idea we had. Another possible vendor extension would be context-aware linting. We could watch the code for issues that might pass compilation but could cause simulation warnings or errors. Possible examples include a randomization issue or impossible constraints, forever loops, case statements and always blocks and other common latches, flip-flops with poor async, set and reset logic, and many others. Anything that could cause a warning or error when you simulate your code is a possible candidate for further context-aware linting. One huge vendor extension that would be possible would be debugger support. If we integrate an interactive command line simulation with the debuggers built into some advanced editors, if you've used other languages like Python and you've done any type of debugging with it, you'll know that a lot of these editors have built-in debuggers that let you simulate and step through your simulation and view variables and other aspects of your simulation right there in the editor. For our case, we usually will launch a GUI from one of the vendors, and we'll have a lot of similar features, plus a few additional features like the waveform and things that are kind of important to our job. But it'd be possible with a LSP and a possible extension to hook into the editor you're using in its commands and let you run your simulation and run it right from your editor, where you could step through your code and view your registers and view your code. And ideally, a deep link to the GUI so that you could quickly open the waves from the editor and bounce back and forth. Essentially, what this would let you do is replace the basic text viewer that's built into the current vendor simulation GUIs with your favorite LSP compliant editor. The text viewers built into them they have some nice features. They have that macro expanding feature we talked about, but you can't edit. You can't, it's a lot of back and forth. And if it was all in one cohesive workspace, it could greatly improve your simulation debug time. So in summary, our industry design and test bench complexity is growing. It's growing and growing, and every year it gets more complicated. We come to DVCon and we learn about how it's going to be more complicated this year than it was last year. A SystemVerilog language server would add many, many convenience features to our editors and other editor tools that will allow us to work on our designs and test benches with a little bit more ease in our jobs. And while they're convenience features right now, they will soon turn into more of a necessity as things grow even more complex. And on top of that, every year we get new college graduates entering the field, and they go through school and they use particular editors in their programming classes, and then they come to work on SystemVerilog, and it feels like they're using a language out of the past because it's missing a lot of things that have become standard across other programming areas of the market. On top of that, a language server protocol would create a new market for supercharged language server upgrades, and vendors love to compete on selling this stuff, and that's a good thing. So how do you take advantage of these amazing features today? Well, you can't, mostly, yet. That's kind of the point of this paper. We urge you to contact your Accelera representatives and urge them to make this a priority. I did say mostly because there are some features which have varying levels of support in some editors on the market today. However, the point of the language server protocol is to separate the features from the editor so that you can have any feature in any editor, and that lowers the bar to entry significantly. So please help us bring our industry into the modern age of programming, and reach out to your Accelera representatives today. Thanks a lot for attending our presentation, and we look forward to speaking with you momentarily in the live Q&A. Thanks.